हेलो स्टूडेंट्स, तो हम लोग आपका मिड टर्म का रिवीजन कंटिन्यू करेंगे। तो कुछ स्टूडेंट्स का शायद अभी तक एग्ज़ाम नहीं हुआ होगा, तो उनके लिए हेल्पफुल होगा। तो मिड टर्म रिवीजन पार्ट 1 में मैंने पहले 2 चैप्टर्स कवर किए आपका, केमिकल रिएक्शंस एंड इक्वेशंस एंड एसिड्स बेसिस एंड सॉल्ट्स। नाउ विल बी कवरिंग द रिमेनिंग 2 चैप्टर्स, मेटल्स एंड नॉन मेटल्स एंड कार्बन एंड इट्स कंपाउंड्स। तो ये दोनों हमारे बच गए थे, इसको चलिए कवर करते हैं। ओके, सो लेट्स बिगिन आवर क्लास। Okay, so first question, what is the first question? Which of the following oxides of iron would be obtained on prolonged reaction of iron with steam? So iron reacts with steam, it does not react with cold water, normal water, even hot water, it reacts with steam. So when you react iron with steam, you get a metal oxide, or we get a combination of metal oxides and hydrogen gas. So iron being lower, relatively low, lower in the metal reactivity series, it is a relatively less reactive metal. So what happens when iron reacts with water? When iron reacts with water, it gives you a mixed oxide Fe3O4, okay, plus H2O. So I have not balanced this equation. If you balance it, I think it is 3, 4 and I think another 4 will be there, sorry, 4H2. It's not water, you get hydrogen gas. Okay, so these are your products. So Fe3O4, it is a mixed oxide of FeO plus Fe2O3. Okay, so basically if you add up FeO and Fe2O3, you will get Fe3O4. Just add it, you should get 3 atoms of iron, 4 atoms of oxygen. So in FeO, iron has a +2 charge, Fe2 plus, and in Fe2O3, iron has a +3 charge. Thus valency of iron in Fe2 plus is 2, valency of iron Fe3 plus is 3. So we learned it at 9th standard atoms and molecules chapter. Valency of ions is the charge that they occupy. So here, so let's see the options. So you have 2 products, combination of 2 products is named as Fe3O4. So obviously FeO is only one of the 2, so it is not a multi correct option question, it is a single correct option. So therefore option A is wrong, option B is also wrong. Individually they are right, but as a combo they are wrong. Fe2O3 and Fe3O4, it is also wrong. Correct option is option C, Fe3O4. So let's try to check it. So if you check it, you will get Fe3O4 as your answer. So Fe3O4, you can also write it as iron 2,3 oxide, another name for Fe3O4. Okay, so we'll continue. Next question, which of the following metals are obtained by electrolysis of their chlorides in molten state? So highly reactive metals, you will need electrolysis to obtain them, like sodium, okay, so potassium, so elements like that. So here 4 like metals are given: sodium, calcium, iron and copper. Copper is less reactive, iron is relatively less reactive, calcium is relatively high reactive, and sodium is highly reactive. So sodium and calcium you should obtain by electrolysis of their chlorides in molten state. Okay. So if you take an electrolytic cell, at cathode, you will obtain so basically if you take an electrolytic cell, okay, you take an electrolytic cell, you take 2 electrodes, okay, negative, positive. Electrolytic cells convert electrical energy to chemical energy. Okay, so in the liquid phase you have molten NaCl, not aqueous NaCl. If you do electrolysis of aqueous NaCl, you have the brine solution electrolysis or chloralkali process, so the products will be different. But in the case of molten NaCl, at the cathode you will get your metal. So you will get Na plus plus E minus should give you Na, sodium atom, sodium metal. So basically this is a liquid NaCl. Okay, you have heated NaCl to such an extent it has from solid it has turned to liquid. So in this your ions exist as Na plus and Cl minus ions. Okay, they don't exist as NaCl crystal. Then at anode you should get chlorine gas. Anode you will get 2Cl minus gives Cl2 plus 2E minus. Okay, so in an electrolytic cell, cathode is your negative electrode, this is your negative electrode, and anode is your positive electrode. Okay, similarly for calcium you will get at cathode your calcium metal, cathode the negative electrode. So Ca2 plus will get converted to calcium metal, and your chlorine 2Cl minus will at anode you will get chlorine gas. So you will get 2Cl minus will give you Cl2 plus 2E minus. Okay, it's just an exchange of electrons. Next, but if it was chloralkali process, then at anode you would have got chlorine gas, at cathode you would have got hydrogen gas and OH minus ions. The OH minus ions along with the Na plus ions which you get from the NaCl, aqueous NaCl, that produces your NaOH solution basically. So you can get sodium hydroxide alkali solution from that chloralkali process along with hydrogen and chlorine gas. Okay. So thus our options are 1 and 2, any option which is 1 and 2 combination that will be correct. So it will be option D. Okay. So sodium and calcium being highly reactive, they are obtained by electrolysis of fluorides in molten state. So basically you are not taking aqueous solution of NaCl or CaCl2, calcium chloride you took for calcium, sodium chloride I have taken for sodium, you are taking their molten state. So you are taking pure NaCl or pure calcium chloride and heating it to a certain extent that they melt from solid to liquid phase. Next what we have? Next we have is the electronic configurations of 3 elements x, y and z are x2, 8, y2, 8, 7, z2, 8, 2. So we have actually 2 ways to solve this. First you can use the electronic configuration to figure it out. So basically all metals or non-metals, they try to reach the nearest noble gas configuration. Another important data is you should remember the elements, all the elements till atomic number 20 for now. Okay, their atomic number, their mass number, please remember. Number of protons, number of neutrons, okay, so get a hang of it, and their valencies. Okay, so x, y and z. So one way is I know x is 2, 8, okay, x is 2, 8. So first shell, K shell and L shell, they are completely filled. So since all the shells are completely filled by electrons, it has a noble gas configuration, it is a noble gas. Thus it does not need to accept or donate electrons, like give electrons to form the nearest noble gas configuration. Thus X is a, noble gases are also your non-metals. So question is regarding metal and non-metal, so noble gases are also your non-metals. Okay. Next is Y. Y has electronic configuration of 2, 8, 7. Thus if it gains one electron, it can form your like nearest noble gas configuration, which will be 18, which will be for 18, which is for the element argon. Argon is a noble gas, so they will try to, it will try to gain an electron either by like by forming an ionic bond or by sharing electrons in a covalent bond. Thus this will be your 2, 8, 7 as it gains electrons. So if it gains electrons, it will form Y minus. So non-metals gain electrons to form anions, metals generally lose electrons to form cations. Again, non-metals generally gain electrons to form anions. Thus it will be a non-metal. So my Y is also non-metal. Next I have got Z. Z is 2, 8, 2. Z is 2, 8, 2. Okay. So again it has 12 electrons, nearest noble gas configuration, K shell, L shell fully filled will be your 2, 8. Okay. So if it nearest noble gas configuration is of neon with 2, 8. Okay. So 2 comma 8 is neon. So if it loses 2 electrons, it can form a cation. Thus it is electropositive in nature. Okay, if Z loses 2 electrons, it forms Z2 plus, which has a noble gas configuration of 2 comma 8. Thus it becomes like it achieves the noble gas configuration. Thus I will say that since it is by the action of forming a cation, it has electropositive nature. Thus it is a metal. Z is a metal. So my X and Y are non-metals, Z is a metal. So let's see which option fulfills all the conditions. So again it is a single correct option type question. So only one option will be correct. So X is a metal. X is a non-metal. Another way to solve this question I would say is, if you remember the electronic configurations of atoms, elements till atomic number 20. Okay. So atomic number 20, so X 2 comma 8, so 10 electrons. So it is my neon. Neon is a noble gas. So if I remember, this is by memory I am taking out. So if neon, so neon is a noble gas which is a non-metal. 2 comma 8 comma 7, 17 electrons, atomic number 17, chlorine. Chlorine is a non-metal. 2 comma 8 comma 2, atomic number 12. Thus it is magnesium. So magnesium is a metal. So these are the two ways. This is the, you are like finding out via logic, this is by memory. Thus Y is a metal. Y is not a metal, it is a non-metal. Z is a non-metal, Z is a metal. So option D, Y is a non-metal and Z is a metal is my correct option. So even X is a non-metal. This is my correct option. So remember, noble gases are your non-metals. Okay. So complete octet. So basically they reach octet configuration. Okay. Like in the case of neon and argon. Hello, Hakai. Okay. Okay. So Hakai, try to solve this question. It is related to electrolysis. Okay. Question is, so these all questions are from your exemplar book. So like I have taken tougher questions so that you can revise faster. So this question is from a third chapter. आपका question ये है कि during the extraction of metals, electrolytic refining is used to obtain pure metals. Refining is the last process in the extraction of metals to get the pure metal as pure as possible. Okay. So which material will be used as anode and cathode for refining silver metal by this process? So your goal is to obtain silver metal. Suggest a suitable electrolyte used for the process. So basically what salt to be used in the aqueous solution so that the solution starts conducting electricity. Okay. And third question is, in this electrolytic cell, where do we get pure silver after passing an electric current? So will the pure silver form at the cathode or will it form at the anode? That is your question. Okay. So Hakai, you can just type in chat what you think is right. So what will be used as anode and cathode? What will be the suitable electrolyte for this process, and in this electrolytic cell where do we get pure silver after passing an electric current? So these three things you have to tell. So you can respond in the chat, Hakai. So you can respond. So if you don't know, you can say, so I can start explaining the solution. Okay, so I will answer it because we have limited time. So anyway, so there are actually two electrolytic cells that can give you silver, but the more better answer would be the one in which silver is the major product, like the major result of the electrolytic process. So what you do is you take electrolytic cell again Electrolytic cell is opposite to that of your battery. Okay, so that's why cathode anode signs might they are a bit different. So in a electrolytic cell, you convert electrical energy to cause a chemical reaction. In a battery, we use a chemical reaction to cause we convert chemical energy to electrical energy. In electrolytic cell, we convert electrical energy to chemical energy. Okay, so what we do is we take electrolytic cell. Okay, so we take impure strip of silver as your anode. Impure strip of Ag as your anode. Okay, and a pure strip of Ag or silver as your cathode. Pure strip of Ag as cathode. Okay, so I know anode is my hi धनंजय, हेलो धनंजय. ओके, सो ये वाला क्वेश्चन हम लोग अभी सॉल्व कर रहे हैं. तो क्वेश्चन आपको तो दिख रहा होगा आपके स्क्रीन पे. तो आई एम जस्ट सॉल्विंग. तो बेसिकली आपको फिगर आउट करना है कि सिल्वर को आपको कैसे मिलेगा इलेक्ट्रोलिटिक रिफाइनिंग यूज़ करके. इलेक्ट्रोलिटिक रिफाइनिंग से आप जो लास्ट में जो सिल्वर का पीस आपको मिलता है आफ्टर ऑल द केमिकल प्रोसेसेस या योर मेटलर्जिकल प्रोसेसेस जो रिएक्शन वगैरह होके, तो वो प्योर नहीं होता. उसको और प्योर करने के लिए वी यूज़ समथिंग कॉल्ड रिफाइनिंग, एंड वन ऑफ द वेज टू डू रिफाइनिंग इज इलेक्ट्रोलिटिक रिफाइनिंग. सो यूज़ एन इलेक्ट्रोलिटिक सेल टू प्योरीफाई द मेटल. सो अभी देखते हैं इसको कैसे करना है. तो अब एक सेल लो, आप इम्प्योर स्ट्रिप ऑफ Ag को एनोड बनाओ, प्योर स्ट्रिप ऑफ Ag को आप कैथोड बनाओ. आपको पता है कि आपका एनोड इलेक्ट्रोलिटिक सेल में पॉजिटिव होता है और कैथोड आपका नेगेटिव होता है. ये मेरा पॉजिटिव इलेक्ट्रोड है, ये मेरा नेगेटिव इलेक्ट्रोड है. ठीक है, इलेक्ट्रोलाइट आप लोगे एक सॉल्ट सोल्यूशन ऑफ द मेटल विच यू वांट टू प्रोड्यूस. सो आई विल टेक AgNO3 एज माय इलेक्ट्रोलाइट. AgNO3 is my electrolyte. Okay, electrolyte basically anything which dissociates into its ions in the aqueous medium so that the medium can start conducting electricity. Okay, there is a flow of electricity in it. So what happens, आपका एनोड में आपका Ag प्लस जो एनोड का इम्प्योर मेटल है वो सोल्यूशन में डिज़ोल्व होना स्टार्ट हो जाता है. तो वो क्या करेगा, Ag कन्वर्ट्स टू Ag2 प्लस Ag प्लस, सिल्वर का वैलेंसी 1 है, Ag प्लस प्लस E माइनस. ओके, और कैथोड पे आपका डिपॉजिट होगा सिल्वर. सो कैथोड में आपका Ag प्लस प्लस E माइनस आपको देगा Ag. ठीक है, तो बेसिकली क्या होता है, ये इम्प्योर स्ट्रिप ऑफ सिल्वर से Ag2 प्लस फॉर्म होता है, Ag प्लस फॉर्म होता है, और कुछ Ag प्लस जो Ag प्लस सोल्यूशन में वो जाके यहाँ पे डिस्चार्ज होके खुद को डिस्चार्ज मतलब Ag प्लस यहाँ पे अपना चार्ज लूज़ कर रहा है बाय गेनिंग एन इलेक्ट्रॉन. वो अपना चार्ज लूज़ करके आपका कैथोड पे डिपॉजिट होना शुरू हो जाता है. तो उससे क्या होता है, आपका धीरे धीरे क्या होगा, आपका इम्प्योर स्ट्रिप का मास थिकनेस सब घटेगा, वो पतला होता जाएगा और आपका प्योर स्ट्रिप बढ़ते जाएगा. तो वो ही आपका गोल है, राइट, कि आपको और प्योर चीज़ चाहिए, इम्प्योर चीज़ कम चाहिए. तो धीरे धीरे इम्प्योर स्ट्रिप का मास घटता जाएगा, प्योर स्ट्रिप का मास बढ़ता जाएगा. ठीक है, तो बेसिकली आप जो सिल्वर मिलेगा आपको वो 99.9% प्योर सिल्वर होगा एट द कैथोड. ठीक है, दिस इज द प्राइमरी वे टू गेट Ag. अनदर वे इज देयर ड्यूरिंग इलेक्ट्रोलिसिस ऑफ कॉपर. तो इलेक्ट्रोलिसिस ऑफ कॉपर भी सिमिलर होगा. आप अगेन एक इलेक्ट्रोलिटिक सेल लोगे. ओके, सो रिफाइनिंग, इलेक्ट्रोलिटिक रिफाइनिंग ऑफ कॉपर, आप रिफाइन कर रहे हो. ठीक है, तो अगेन आप क्या करोगे, एक इम्प्योर स्ट्रिप ऑफ कॉपर को आप एनोड लोगे. ठीक है, ये मेरा एनोड है, पॉजिटिव इलेक्ट्रोड है इलेक्ट्रोलिटिक सेल में. प्योर स्ट्रिप ऑफ कॉपर को आप कैथोड लोगे. ओके, तो ये मेरा एनोड है, इम्प्योर स्ट्रिप ऑफ कॉपर, एंड तो ये मेरा पॉजिटिव इलेक्ट्रोड है, प्योर स्ट्रिप ऑफ कॉपर मेरा नेगेटिव इलेक्ट्रोड है जो कि मेरा कैथोड है. ठीक है। इसमें आप इलेक्ट्रोलाइट लोगे कॉपर सल्फेट, CuSO4 सोल्यूशन, ठीक है। तो इससे क्या होगा, तो धीरे धीरे अगेन सेम रिएक्शन होगा, इसका कैथोड पे आपको कॉपर डिपॉजिट होना शुरू हो जाएगा और Cu जो कि आपका एनोड का है वो डिसॉल्व होगा आपके इलेक्ट्रोलिटिक सोल्यूशन में। तो Cu2+ बनेगा, फिर कैथोड में Cu2+, फिर कॉपर बनेगा। इसमें क्या होगा, एनोड के नीचे कुछ इनसोल्यूबल मटेरियल आपको मिलेगा। तो वो मटेरियल में वो इम्प्योरिटीज़ एक्चुअली होते हैं जो इम्प्योर कॉपर स्ट्रिप में होते हैं। तो उसमें से आपको सिल्वर मिलता है, गोल्ड मिलता है, फिर एंटीमनी मिलता है, ठीक है। तो दिस इज़ वन माइनर वे टू गेट सम सिल्वर. Major way is this: you use electrolysis to get your silver from the impure silver piece. Okay guys, so you can get silver two ways. This is the primary way, that is also a very mild way to get silver, because electrolytic refining is an expensive process. तो ये expensive होता है, तो कुछ पैसा वापस लेने के लिए जो भी मैन्युफैक्चरर है कॉपर का, वो क्या करते हैं, सिल्वर और गोल्ड को यूज़ करते हैं टू गेट बैक सम मनी. तो गाइज़ हिथा और हकाई आपको अगर समझ आ गया तो प्लीज़ रेस्पॉन्ड इन द चैट लाइक हाउ यू कैन गेट दिस, so I can move to the next question or I can explain it again. So please respond in the chat if you understood these two electrolytic processes, and the major one is this one, minor one is that one. ये insoluble impurities को हम लोग एनोड मड बोलते हैं, ठीक है, एनोड मड. So guys please respond in chat, हिथा और हकाई. So अगर आपको if you guys understood, then only I'll move to the next question, or I can explain it again. Guys please respond in the chat if you have understood, then only I'll move forward. If you have any doubt you can also say, so I can explain again, that's not a problem. Okay, I'll continue. Okay, so because we have limited time, so if you have any doubt you can ask in the next class if you have left the class and or there's some issue you're not able to respond. Okay, so we'll go to the next slide. So just remember, electrolytic refining, you always get the pure metal at the cathode, that's the important part, and it's very rarely that scenario. Some cases you can get like a minority impurity metal at the anode. Okay, so next is a non-metal A, which is the largest constituent of air when heated with hydrogen in a 1:3 ratio in the presence of iron catalyst, gives a gas B. On heating with oxygen, it gives an oxide C. If this oxide is passed into water in the presence of air, it gives an acid D, which acts as a strong oxidizing agent. So acid D is a strong oxidizing agent, provides oxygen. Okay. So identify A, B, C and D. To which group of the periodic table does this non-metal belong? Okay. So this is a question. Okay. So guys, you can try if you are in the class. Simultaneously, I will also solve it. Okay. So first part of the question is your Haber's process. So I have taught this in class also few times. So if you take nitrogen, non-metal A, which is the largest constituent of air. So non-metal A, which is the largest constituent, obviously it is nitrogen. Okay, nitrogen is 78% by mass in our atmosphere. Nitrogen heated with hydrogen, H2, 1:3 ratio. Okay. In the presence of a catalyst, iron. So iron is your catalyst. You also need high temperature, 400 degrees Celsius temperature and high pressure for this reaction to happen. 200 atmospheres. Atmospheres is the like unit of pressure. Like Pascal is a unit of pressure, atmosphere is also unit of pressure. So nitrogen and hydrogen, when they react in a molar ratio 1:3, they give you ammonia. to NH3. Okay, this process is known Haber's process. So you get your fertilizer from this process, like it is the bedrock of our agricultural produce. Next, on heating oxygen, on heating with O2, it gives an oxide C. So the same gas, so non-metal A, this is my non-metal A, gives a gas B. So ammonia is my gas B. So I've got A and B both. Next I have is if nitrogen reacts with oxygen. Okay, so this is again the oxide which is in your course. So it can form different oxides, but this one is in your course. So nitrogen plus oxygen, it will give you 2O2. O2 gives me NO2 gas, 2NO2. Okay, this is my gas. So this is my oxide C, nitrogen dioxide. The nitrogen dioxide, when passed through water, it gives you nitric acid. So NO2 gas, when it is passed through water, it gives me nitric acid. It gives you HNO3 plus nitrogen monoxide also. Okay, so this is my reaction. So HNO3 is a highly, it's oxidizing agent, it oxidizes substances. Okay, so provides oxygen. So this is my nitric acid, which is my D. So A is nitrogen gas, B is ammonia gas, C is nitrogen dioxide gas, and D is your nitric acid. D is nitric acid. Okay. Nitric acid is an oxidizing agent. How? If nitric acid, so when iron and nitric acid react, they don't give, it doesn't give H2 gas. What happens is the H2 gas, because of the presence of nitric acid, it oxidizes itself to water. Okay, that's why you don't get hydrogen gas when iron and nitric acid react. Okay, so you get ferric nitrate, FeNO3 whole thrice, plus you get some nitrogen monoxide, plus you get water. Okay, no H2 as it gets oxidized to water. Okay, that's why nitric acid is an oxidizing agent. It provides oxygen for oxidation of other species. Okay, so nitric acid is also used in many other reactions where it is acting as an oxidizing agent. Okay, so these are my A, B, C and D. So guys, if you have understood, please respond in the chat, then only I'll continue. If you have not, you can say. ओके गाइज, सॉरी फॉर द डिस्ट्रप्शन. सो गाइज, इफ़ यू, आप लोग को अगर समझ में आ गया देन प्लीज़ रिस्पॉन्ड, नहीं आया तो आप लोग बोल सकते हो, देन आई कैन एक्सप्लेन अगेन. इट्स मोर ऑफ अ रिमेंबरिंग, लाइक मेमोरी बेस्ड क्वेश्चन, बट स्टिल. सो हाउ योर A, B, C and D are formed here. Okay, so Hitha and Hakai, you can say. Okay, I will then continue. Next slide. Another question, which of the following is the correct representation of electron dot structure of nitrogen? So electron dot structure is basically, so nitrogen has 5 electrons in its valence shell, and its goal is to reach the nearest noble gas by forming covalent bond with itself, another atom of nitrogen, to reach 10 electrons around it. Okay, like So by forming 10 electrons around it. So basically its valence electron shell should contain 8 electrons, and I know nitrogen forms triple bond with itself. Okay, nitrogen forms triple bond with itself. A single atom of nitrogen, it has 5 electrons around it. Sorry. So nitrogen's electronic configuration is 2, 5. Its atomic number is 7. So it will have 5 electrons in its valence shell. So I've got 2 atoms of nitrogen forming a triple bond. So every triple bond means 6 electrons are being shared. So these each single bond, they contain 2 electrons. So obviously 6 electrons being shared over the 3 bonds. So triple bond means 3 single bonds. Okay, like 3 bonds, not single bonds, like 3 bonds. Okay. So obviously in a triple bond there will be 6 electrons in between nitrogen, then 2 electrons will not be in bonding as per the valence shell. So the electron dot structure should look like this. Okay. So any structure which shows this, or at least just the electrons without these circles, that will be my answer. So circles represent the atom basically. So among the options, option D has between 2 nitrogen 6 electrons and 2 electrons are not in bonding. Okay, so they are non-bonded. Lone pair, you will learn in higher grades, they are said lone pair. Okay, so obviously this will be my option D. Okay, so like I did circle, so here I have done something like an oval, but you can also give a circle. So next question. Next question is, select the statement which is true for soap micelles. So micelles are like sort of like clusters which take your dirt particles. Okay. So okay, so basically soap, so micelles basically are the cluster. So basically they have a, so the soap molecule, it has a hydrophobic end, hydrophilic end and hydrophobic end. So the hydrophobic end sort of forms a cluster around your dirt. So whatever dirt, oil, grease is, it forms a cluster around it, and when you wash it off using water, it just takes the dirt and grease with itself. So you have to also rub it a bit, and then it escapes. So you can clean your clothes using water, using soap. Okay, so they form a cluster. Okay, okay, so in this cluster, this is your micelles. Okay. Plural is micelles. Okay, so if you have more than one, it will be a micelles. So this cluster thing, this is your micelles. Okay, so what is this? So this interior part, it is your hydrophobic. It hates water, so it stays away from water. And this charge part, it is your hydrophilic. Okay, it loves water. So how will this cluster form? So this ionic, this charge part is basically your so basically C17H35, C17H35, C double bond O, O minus. Okay, this is your charge. Okay, so wait, I'll do this again. C17H35, C O minus. Okay, this charge part, again charge part is attracted towards water because because of polarity. Okay, so you will learn a concept. So water has some partial charges in it. Okay, so water is like HOH. Okay, and oxygen is an electronegative element. Electronegative element means it attracts the shared pair of electrons towards itself in a covalent bond. So between oxygen and hydrogen there is a shared pair of electrons, so 2 electrons each. So this is attracted towards your oxygen, both the electrons. Okay, so what happens, oxygen develops a partial negative charge, your hydrogen develops a partial positive charge. So because of this existence of these charges, partial charges, and the existence of charge on your soap molecule, you get attraction of the hydrophilic end towards this. So hydrophilic end is this charge part. Okay, this is what is your minus thing. Okay, minus. So this is your hydrophilic, and this part, this is your carbon chain. Carbon chain does not have any those charges or partial charges, thus it will be my hydrophobic end. So it will, but it this hydrophobic end but can attract these dirt or grease particles to itself. Now again you will read in higher grades polar and non-polar. So because of polarity of the material, they can attract the grease and dirt particles to itself. Okay, thus this is, but it does not have any charge or partial charge, so it is hydrophobic, it fears water, it stays away from water. So this is my hydrophobic. Okay, so the minus part is my hydrophilic, so ionic end, that will be my ionic end, charge part. Ionic end of soap is on the surface of the cluster and the carbon chain is in the interior of the cluster. So carbon chain, this hydrophobic part, it sometimes also said to be carbon chain. Okay. Okay. So if you add a Na plus, this thing will be called sodium stearate. Sodium stearate is sort of like a soap material. Okay. Okay. So you can see the minus part or the C double bond O minus part, it is on the outside of the cluster. Cluster means that micelle cluster, while the carbon chain is in the interior of the cluster. So this can attract these dirt and grease particles. So that is the logic. So it traps the dirt and grease particles, and the hydrophilic part, it contains it and is stable in water, because in water dirt and grease, just by simple water it will be difficult to remove it. Okay, again because of polarity and non-polarity, you will read in higher grades, but with this you can remove it easier, in a easier manner. That is how a soap works. Okay, so here option A मेरा सही होगा. Okay, so this is my micelle. So that Na plus I did not include. Okay, so here there is a minus part. Okay, minus, it's a minus Na plus, minus Na plus, minus Na plus, that's C double bond O minus, that part, minus Na plus, minus Na plus. Okay, so that is the short ionic part, the charge part, and this cluster is your micelle, long hydrocarbon chain, like I had explained, that was your C17H35. C17H35 COO minus Na plus is your sodium stearate or a soap ionic compound. Okay, so this is your soap and this entire thing is your micelle. So we will go to the next. Ethene is formed when ethanol at 443 Kelvin is heated with excess of concentrated sulfuric acid. What is the role of sulfuric acid in this reaction? So when ethanol is C2H5OH. Okay. So guys, if you are have rejoined, you can always say, if you have not understood, I can always explain again. Hakai and Dhananjay. C2H5OH is my ethanol. If you heat it to 443 Kelvin and use concentrated H2SO4, okay, so what you get is So what you get is ethene, C double bond C, H, H, H and some water. Okay. So this is your reaction. This is called dehydration reaction. This is dehydration. So you remove water basically. Okay. So because you remove water from ethanol to form ethene, okay. So at one stage, so there is a mechanism for it. So there is a way by which the water is removed. At one stage during, so there are a couple of steps by which this is converted to this. So one of the steps you lose water because concentrated H2SO4 removes water and causes dehydration of ethanol. It is called to be your dehydrating agent. So here concentrated H2SO4 will be your dehydrating agent. So how, in which steps it works, you will read in higher grades, but I can tell you a few part. Okay. So first step is actually you protonate the alcohol. So basically your alcohol looks like this: H, 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 C, O, H, H, H. So this is ethanol. Okay. And then it takes one proton from your sulfuric acid. Okay. So it takes one proton and it latches onto it. Okay. So it forms your so this is the first step. So basically you will get at the end, again heat is required. So you will get some CH, H, H. So protonated alcohol, this is called a protonated alcohol. Okay. The oxygen in the alcohol will have an extra hydrogen. So basically that's why, because after the addition of a proton, H plus will be added from the sulfuric acid. This is a protonated alcohol. Okay. Okay. So in the next step actually what happens, this HSO4 minus okay. Okay, so this is how, like, first step of this reaction. So it's a multi-step reaction. So I've just showed you one of the steps. There are further steps also. Okay. So I gave an extra, sorry, this is wrong. Okay. This hydrogen was extra, sorry. So this oxygen molecule, so initially it had one hydrogen, so I made an error here. Finally it will have two hydrogens, so you will tell it to be a protonated alcohol. Okay. Next what happens actually, I can tell you actually, so this HSO4 minus, so after removal of this one of the hydrogens, okay, it will give you HSO4 minus. Okay, HSO4 minus, okay, HSO4 minus, okay, because sulfuric acid sort of will look like this then, double bond O, double bond O, OH, so one of the H is removed. Okay, so one of the H is removed. This H has been taken by this alcohol functional group. Then what happens, this HSO4 minus, it takes this hydrogen. Okay, and this bond will come here and this bond will break and oxygen will take the two electrons between the carbon and oxygen bond. So finally you should get you will get double bond O. So you will get ethene plus you will get some H2O and H2SO4. Okay, so this will be your reaction. Okay. Okay guys, actually there's an error here. Okay, so sorry guys, there's an error I think in this reaction. Okay, this reaction there's an error. Okay, so for now just don't, so I'll tell you the exact sequence of reactions which gives you ethene in the next class. Okay, there's an error here. Okay. For now, just remember that H2SO4 acts as a dehydrating agent. Okay. So in the next class, I'll give you the entire reactions. There's some things that are not right in that sequence of reactions. So I'll give you the sequence in the next class. For now, just remember this is your base reaction, and in one of the steps, sulfuric acid removes your water molecule from whatever species is formed. That's why it is said to be a dehydrating agent. Okay. So please, really sorry for this mistake. So there are certain steps which are actually wrong. So I'll give you the correct steps in the next class. And this is your balanced chemical equation. The equation is already balanced, I think. C2H5OH. So ethene, C2. This is your C2H4. Ethene is C2H4 plus H2O. So this is my balanced chemical equation. Okay. So that part please don't figure out for now. So there was an error in that. So I'll give you the correct step of reactions in the next class. Okay. Okay. So next slide. Sorry for the error again. So on next Monday, I'll give you the correct steps of reactions. Okay. So we'll do the last question, I think, for today. So last question is a compound C, molecular formula C2H4O2. So C2H4O2 is that for a carboxylic acid with 2 carbon atoms. So obviously it is your acetic acid or ethanoic acid. So CH3 C double bond OH. So this is my C2H4O2. So this is my compound C. Okay. So compound C reacts with Na metal to form a compound R and evolves a gas that burns with pop sound. So this I have taught before in your metals and non-metals chapter, no, acids, bases and salts chapter. So any metal above hydrogen in the reactivity series reacts with 3 acids, dilute HCl, dilute H2SO4 and acetic acid, which is in your course, to give you the metal acetate plus your hydrogen gas. So CH3COH compound C, when it will react with sodium, it will give me sodium acetate CH3COONA. Okay. Plus it will give hydrogen gas, so H2 gas. So this is my sodium acetate or sodium ethanoate. Some people, you can write it sodium ethanoate or acetate, both are correct. Okay, because CH3COH, it is said to be ethanoic acid as well as acetic acid. Okay, that burns with a pop sound. So hydrogen, when it will react with oxygen plus O2, it will give you H2O. So this happens with a release of energy, release of sound, which is your pop sound. Sound as well as heat and some light also. Okay. So compound any metal to compound R. So sodium ethanoate or acetate is my compound R and evolves a gas that burns with a pop sound. Okay. Compound C. So again compound C is your acetic acid. So compound C, which is my acetic acid or ethanoic acid, on reacting with alcohol plus an alcohol, okay, in the presence of acid, forms a sweet smelling compound. Sweet smelling compound are your esters. So in the presence of an H plus acid, you will get ester, okay, CH3 COO CH3. Okay, so this is my sweet smelling compound. Okay, CH3COO. So on reacting with alcohol, so alcohol I will take, I made an error here. So alcohol I will take methanol, okay, not ethanol, I will take methanol. If I take methanol CH3OH, I will get my this ester. Okay, this is an ester which is sweet smelling. Okay, and you will get some water also plus H2O. Okay, so this is my ester. So alcohol A. Okay. Presence of an acid from a sweet smelling compound S. So here actually for alcohol A, it has not specified what is the alcohol A. Okay. So I am taking methanol as my alcohol A. Okay. So there is an error in the question. Alcohol A, the question has not specified. So there can be many n number of alcohols. So I am taking methanol, which is CH3OH. If I take methanol, I will get this ester, which is CH3COOCH3, and some water. Now, okay. So if I take this, so last reaction will be CH3. So CH3COOCH3 is my compound S. This ester is my compound S. Then CH3COOCH3. Okay. If you add a base to it, so on addition of NaOH to C, presence of an acid forms the sweet smelling compound S. Okay. Reacts with Na metal to form a compound R. Okay. Time up. 4 minutes. 55. Okay. Okay guys, actually there is a lack of time for this question. So I'll solve this question in the next class. First thing in the next class I'll solve this question. So I've solved till your compound S. Okay. So after that we will check the other parts in the next class. Okay. So we have to figure out what is your R. So actually for A they have a reaction. Okay. Okay, for A they have a reaction. So wait, let us check again if we can do it actually in the time. Reaction reacts with Na metal to form a compound R. On addition of NaOH to C, it also gives R and water. Okay. S on treatment with NaOH solution gives back R and A. Okay. Okay. So S is my ester. Okay. Next, if you take addition of NaOH to C, so C is my acid, which is acetic acid. So CH3COOH plus NaOH. So CH3COOH is a acid and NaOH is a base. So you will get sodium acetate CH3COONA plus some water. Okay. So this is my compound C. One reacting with NaOH gives my compound R. Okay. So this was also my compound R. Sodium ethanoate acetate, again I am getting back. Next, if you treat S, so if you take this CH3COOCH3 and you react with some NaOH, it again also gives back R and A. Okay. So you will again get back your alcohol and your carboxylic acid CH3COOH. Okay. So this is my last reaction. So R I have got, C I have got, A I have got. I have taken A as my methanol. Okay. So how can you get methanol? So the trick is here, CH3H6O2. Okay. So methanol actually you can, because when you react the acid with methanol, so acid is your acetic acid CH3COOH. If you react with methanol, then only you will get this ester CH3COOCH3. So that ester formula is CH3H6O2. Okay. From this you get the clue that the alcohol you have to use. So this is your alcohol. Okay. So in esterification, the alcohol and the acid combine in the presence of water to give you an ester. Okay. So one carbon atom more. Okay. So that was the goal. So C is your acetic acid, R is your sodium ethanoate, A is your methanol, S is your CH3COOCH3. Okay. So guys, so this will be your answer. Okay. Next, Guys, so please visit our platform embibe.com. I've taught you the theory, so you can attend the class. Okay. And guys, regarding the step of equations in the dehydration reaction, so I'll tell you in the next class. There were certain errors in the steps that I gave you, so that's why I would request you to wait for the next class. So please don't follow the one I gave today. And अगर आपको ये class पसंद आया तो please like the video and subscribe to our channel and click on the bell notification icon, and thank you for attending the class.
Keep imbibing. We believe in you.